Hello everyone, welcome back to my channel Programming with a Purpose. This is the lesson 14 in the beginner series of learning iOS development using Swift. We are covering now the advanced concepts of Swift that include the protocol lesson. So they are the blueprints, methods, properties and other requirements, and they are adopted by a class structure or enumeration which provides the actual implementation. So you can basically provide the requirements that any conforming class will adhere to, as well as you can perform and provide additional functionalities by extending the protocol. So this is the syntax we are going to follow with the keyword protocol, and after that the name of protocol. If you are going to adopt it using a struct, you can use the keyword struct, name of the structure, and then the list of protocols it is going to conform to. And the rest you can see the syntax for a class which can basically extend a superclass and then it can conform to certain protocols. So here I am going to copy the struct that I have created in the lesson of extensions and I am going to paste it, and here I am going to create a protocol with the name. So this protocol has a property with the name and it has a string with a getter. So you can see that this is the minimum requirement that is basically required for a protocol. The property, if a getter and a setter is mentioned, then that means a getter and setter should be provided, and the property cannot be read-only or contains a constant. So here you can see that I have extended the struct by adding an id. It already has name and ingredients. After that we are creating a struct person that is basically adopting this protocol, or in other words it is basically conforming to this protocol name, and it has these two properties, name string and age. So you can see that both of these structs have adopted the name property of the protocol name. Here I am writing the getter for the name, which is basically returning Hania plus last name. So after that I'm printing the name, and as you can see that the name is printed successfully. And when we are going to print the name of the recipe, since nothing is stored, nothing is printed. But here I've mentioned a constant value of recipe here. So a recipe name is printed with the name recipe. After that we are adding another method to our protocol name with the name count name length. This is a very obvious and simple method. You can obviously add more complicated methods according to your needs. And here you can see that the error generates, basically tells you that it does not conform to the certain protocol, and when you click it, it is going to add the stubs and you can later add the body to it. So here I am adding the function count name length to both of these structs that have adopted our protocol name. So here I am returning the count of the name length. So again I am going to call person.name, and it is going to give me an error because it is telling us that protocol methods must not have bodies. So I have accidentally added the body to the protocol. So protocols are just blueprints. You do not need to add a body to the function. So once I fixed it, you can see here that the name is printed and the name length is printed. Now this is the name length for recipe. So 6 is printed. So it means that the function and the method is working fine. Now we are going to add a mutating method to our protocol with the name capitalized name and return type string. So here I am adding the mutating function inside the struct recipe, and as you can see that I am going to add the body here with the returning of name dot capitalized. So I am going to return name in the capitalized version. Also I am going to add the same function inside the struct person. You can obviously add different bodies inside each of these functions when adopted by different structs or classes. It is giving me this error that cannot use mutating member on immutable value. So it means that we need to basically store the instance in another variable of type var, and then we are going to basically utilize it to call the method. So here you can see that I have changed the capitalized to uppercase so that the result is visible, and both of the name of person and recipe are printed. So after that we are going to write an initializer to our protocol, and then how we are going to call it I'm going to show you here. So in a struct you can write a simple init method with the required parameters, and here you can basically write self.name is equals to name to distinguish between the name that belongs to the recipe and the name that is passed as a parameter. Now I am converting my struct person to class person, so that I'm going to show you how you can basically conform a class to a protocol. So all of the functions are fine. There is a slight bit issue with the mutating function, so we need to remove this keyword mutating, and we need to add the init method with the keyword required. So this is how it can conform to the protocol name. So I have removed the mutating keyword and the error is gone, and here I am going to add the body of the init method. So self.name is equals to name. So it is giving me an error, cannot assign to property. That is only get only property. Since it does not have a setter, so we need to add a setter here. So here I am going to add a setter, which is basically going to be the new value. So here I'll be uncommenting some of the lines and I'm going to play the code, and we need to pass the name here. So here I'm passing the name, and the name is simply printed hania.header because the value is not changed. The value we are passing is not basically appended to the getter. So we need to update the getter and the setter here. So I'm adding another value of property of first name, and I am adding a constant value here, and we are going to use first name plus last name in the getter. And also I am going to basically copy it inside the setter. So this is what we want to set this value to, and self.firstname is equals to name. Now after updating all of these changes, you can see that once I print the capitalized name, Ahmed Haider is printed. So I'm adding some of the space here so that the first name and last name are separated by a space. So this is how you can basically use an init method inside a class that conforms to a protocol. So I have covered up till now function, mutating function, properties that can have a getter and a setter, and then an init method. So this is all that is covered up till now. Now we are moving to protocols as types. So protocols can also be used as types or as collection array dictionaries. I'm going to show you few examples here. So basically we already have a protocol with the name. So here I am creating an instance of that protocol with the variable name myPerson, and in myPerson you can pass a person as well as you can pass a recipe, because both of these conform to this protocol name. And here you can create an array with the type name, which is a protocol, and you can append myPerson to that array. So this is how you can print the array. So here it is printing the 0th element, and here you can print the name of that first element, which is Ali Haider. So this is how you can basically create an array of a protocol. So I am basically here commenting out all of the print statements so that we can move to the next topic, which is basically delegation, adopting the protocol in one class and passing it as an argument to another. So here we can basically use it as a type, which is normally known as delegation. So we have created a protocol with the name convention delegation, and here I am copying the function capitalize name, and after that I am just leaving the signature here and removing all of its body, and also another function that is basically if alphabets only. So these are just the demo functions to show you how you can basically utilize these functions for the delegation of a protocol. So here we have created a class with the name handler, and here we have provided a weak variable delegate with the name conventional delegate, and it is an optional. We have created an empty init method. You need to add anything you want to inside this name handler init method. After that we have created a function print name, and it is going to get the name from the capitalized name function, and then it is going to basically return it the value. So here it is giving me an error because the name protocol is not passed as a parameter to capitalize name and the other function. So we have added that, and here we are printing the name inside the function print name. So this is how we can implement a delegate. Now we are going to call this delegate inside another class by conforming a test class to name conventional delegate, and it will basically give us an error, and here we need to implement the functions that are mentioned inside the protocol. So here we have provided the bodies of both of these functions. Capitalized name is alphabets only. So after that, we are creating an object of the class test class. Also, we are creating an object of name handler. So we are going to pass the name handler dot delegate the test object. So after that, we are going to call dot print name on name handler instance. Instance and objects are the same things. So here you can see that the class test class is basically the implementation, and name handler basically covers all of the delegate calling. And here, this is how you are going to print the name using a delegate. So Ali Heather is printed. After that, we are moving to extensions. So basically, you can extend any type like class, structure, or enumeration by adding further protocols to it by using the keyword extension, name of the class or structure, and then adding colon and the name of another protocol. So after that, here I am going to show you, if you want a protocol to conform to a simple class, you need to add colon any object to it. Next, we are going to move to a protocol, new protocol, which is going to basically extend a previous protocol. So this is basically known as inheriting a protocol. So the new protocol has inherited the name protocol and it has added another function to it, improved conventions. Now we are moving to another feature that protocols offer is basically you can mark a function as optional, which means that you may or may not adopt it inside the class or structure that it conforms to. So here I mentioned a function as optional, and the requirement for making is optional by adding a macro at the rate of Objective-C, which is generally used to make the code available to Objective-C runtime. That is a requirement for using optional. So here we have created a function and we need to add that. So here I am creating another class test, which is the name with another test, and it is basically conforming to the new protocol. And you can see that it does not give me an error, which means that the usage of the function improved conventions is not necessary for adopting this class. But when I've added a simple function to it, you can see that it has given me that error. It means that this function is necessary. So if there is a requirement that one function can be added to one type of a class and other classes do not need to necessarily implement it, we can mark it as an optional with the macro at the rate of Objective-C. So here I am basically showing you how you can extend a protocol. So you can use the keyword extension and the name of the previous protocol, and you can add the further functions and properties to it that can be added to the previous protocol. So here I am going to show you another feature of protocols, which is conditional conformance. It means that a collection will only adhere to a certain protocol if its elements adhere to that protocol. So here we have created an extension of array that will only adhere to name if each of the element adheres to name. So here you can see that it is giving me an error. So I need to implement all of these functionalities, these methods, and these properties. You need to provide the bodies here for this extension of array to work in case of conforming protocol. So this is all for protocols. I hope you have learned something from it. Do not forget to subscribe to my channel, like and share this video, and thanks for watching.